Hello everyone. Today we'll be solving number 53 maximum subarray. This is actually a very classic problem that you definitely have to know before the interview. It has 14,000 likes. Let's hit it a like and 600 dislikes. And then, it's considered being easy, but it's not that easy of a problem. But if you know this algorithm, it's called Cadence Algorithm. You can solve this question in your upcoming interview. So let's read the prompt first. Given an integer array nums, find the contiguous subarray containing at least one number, which has the largest sum, and return its sum. A subarray is a contiguous part of a subarray. So what does this mean? Let's say we have this array, -2, 1, -3, 4, -1, 2, 1, -5, 4. So contiguous subarray is the sum of numbers going in order, which will produce the largest sum. So for example, -2 and 1, this is a subarray. -2, 1, and -3, this is a subarray. The entire array is a subarray. We can take 4 and 1 as a subarray. So all of those possible combinations and return their sum and see what will give us the largest sum. We cannot, however, do, let's say, 1, 4, and 2 because it's not contiguous. So we have to do contiguous subarray. So what is the naive approach to solving this problem? So in order naive approach, we can just sum all of the numbers together, all the subarrays. So let's say this subarray, and then go this subarray, this subarray, this subarray, and it will be nested for loops. It will be on of n square solution. But how can we do it better? And the way we can do it better is actually using something called Cadence Algorithm. So how does Cadence Algorithm works? So we'll have two variables. First call current sum, and then we have maximum sum. So the current sum will basically keep track of the current contiguous subarray sum, and the max will compare if the maximum is larger than the current, and it will update the maximum. But how do we calculate the current subarray? So we first start with -2, and then we go to the next element, and we'll ask the question for current sum. Is -2 and 1 larger than y by itself? And in this particular case, 1 is better than -1. So our current sum would be 1, and our global sum, called maximum sum, also will be 1. Then we'll ask our second question, is -3 better than 1 plus -3? -2 is better than -3, so our sum will become -2. But then what is the larger, 1 or is -2? It's actually 1, so we'll keep 1. Then we'll ask, what is better, 1, -3, and 4 combined, which is 2, or 4? And we know the answer 4. 4 is larger than 2, so we create 4. We put 4 as a current sum. And then we say, what is larger, 4 or 1? And we update to 4. Then we go, what is better, 4 plus -1 or -1 by itself? So 4 plus -1 is larger. It gives us 3 as an example, as a result. And then we're going to ask, what is better, 3 or 4? 4 is better, so we keep the current sum. Then we're going to say 4 minus 2 and 2. So it's 5. Is 5 better than 2? Yes, it is. Then we update it to 5. And then we say, what is better, 4 or 5? 5 is better. And then we keep going. Then we say, what is better, 4 minus 2 and -1 and 2, 5 plus 1 or 1, 6 or 1, 6. So we update to 6, and we say 6 or 5 better, 6 is better. Then we say, what is better, -5 or sum of all those numbers? Sum of all those numbers is better, it's 1. So we'll keep 1 here. But then 6 is also our maximum. And then we're going to go to the next number. We say, what is better, 4 or 6 or 5? 5 is better. But then 6 is better than 5, so we return 6 as a result. So keep this little diagram over here, and let's code it out. So let's code it out in JavaScript. So say let maximum sum, so this is maximum sum, equals to first element. So currently we put it as -2. So we put -2 here, kind of fill out diagram, -2 here. And then we're going to say what? Then we need the current sum. So we say current sum is equal to the same nums of 0, so the first element of the array, and then we'll loop over the array itself. So we say for let I equal 1, because we already look at first element. I is less than nums.length I++, and then we say, okay, what current sum will need to be? So current sum will need to be mass.max, so maximum of which numbers? Of current sum, you know, minus 2 and 1, it's a current sum. Or, so minus, on like when we go to 1, we have current sum as what? Minus 1. What is better? Minus 1 plus 1 or 1 by itself? And it's 1 by itself. We say current sum plus nums I or nums I by itself. So we're saying, is minus 2 and 1 is better than 1? No, it's not. So 1 is better than minus 1. So that's why we set current sum as 1. And then we have to ask, what is maximum sum? We need to update maximum sum. Maximum sum is what is better, minus 2, which is currently our max sum, or what we calculate the new current sum, 1. So what is better, minus 2 or 1? It's 1. So we say mass dot max current sum or maximum sum, and then the maximum sum is better. And then at the end of the day, we'll return maximum sum. Okay, let's go over this code one more time. So first we have minus 2 and minus 2 as our max and current max, max sum and current sum. Then we go to 1 and we say, what is better? Minus 2 and 1, current sum plus nums of I, it's minus 1, or nums of y, 1 by itself. 1 is better. So we say current sum equal 1. And then we say, what is maximum sum? What is better? Current sum, which is 1, or max sum is minus 2. It's 1. And we update 1. And then we keep going just like that. And at the end of the day, we return 6. Okay, let's submit and see how we've done. Some error. Let's see. Let's fix it. Sorry, misspelled length here. Let's submit one more time. And we get 44 in speed and 99 in memory usage. So this is how you solve 53 maximum subarray, which is very, very classical problem and really good to know to the interview. Later, I'll be solving the maximum product sum, which has completely different solution, but also really good to know for your interview. If you like it, please give it a like and subscribe, and let me know down in the comments below which problem you want me to solve next. Thank you.